Now that we've seen what metals can reduce hydrogen ion H plus to H2 gas easily, let's look at what species make good oxidizing agents and good reducing agents. I want to take a look at these three molecules, SO2, PbSO4 lead sulfate, and manganese dioxide or manganese 4 oxide. When I take a look at Appendix L, I can find all of these reactions back there, except for I couldn't find any SO2 reactions, so I found those in another source, but I've written them down here for you so you can see what the potentials are for each of these. I want to start out by taking a look at which of these species do you think would be the best oxidizing agent, right? So is it SO2, lead sulfate, or manganese 4 oxide? And so if I'm looking for an oxidizing agent is, remember, something that gets reduced. And in every case here, the MnO2 plus 2 electrons, MnO4 minus plus 3 electrons, MnO2 plus 2 electrons, so on and so forth. In all of those cases, the species on the left is being reduced. And so if I want an oxidizing agent, all of those things on the left-hand side are oxidizing agents. And so what I see here is that MnO2 can be an oxidizing agent, MnO4 minus can be an oxidizing agent, PbO2 can be an oxidizing agent, lead sulfate can be an oxidizing agent, sulfur dioxide can be an oxidizing agent, and so can the sulfate ion. I want to know which of those is the best oxidizing agent. Remember that if E is going to be a positive value, then it is going to be a spontaneous reaction. Right? Now I've just written half reactions here, so I can't say that these reactions are spontaneous or not. The half reactions can lend you towards spontaneity. But of all of these, which one gives you the best oxidizing agent? Is it MnO2, is it PbSO4, or is it SO2? And so when I take a look at these, I see MnO2 here giving me a positive 1.23 volts, and that one is the most positive of the three species that I see. Right? The next one, is it lead sulfate or is it SO2? Well, the lead sulfate, if it's going to be an oxidizing agent, gives me a negative potential, whereas the sulfur dioxide gives me a positive 0.401, right? And so I find that as far as oxidizing agents go, MnO2 is a better oxidizing agent than the sulfur dioxide than the lead sulfate. So that would be, excuse me, my ordering of good oxidizing agents to weakest oxidizing agents. Now suppose I turn the question around and say, okay, which of these three species would be the best reducing agent? And so if it's a reducing agent, that means it has to be oxidized. And the only species on these half reactions being oxidized are those species in the products. So MnOH2 gets oxidized if the reaction goes in the reverse and becomes MnO2 plus 2 electrons, right? So the MnOH2 is a reducing agent because it gets oxidized, and all the species here on the product side are going to be reducing agents. And so which one gives me the best? Is it MnO2, so is it this one, or is it lead sulfate, this one, or is it SO2, this one? All right, so we need to be a little bit careful here, because what I'm proposing to do is to turn these reactions around so that the MnO2 goes to MnO4 minus plus 3 electrons. And if that's the case, that's a negative 0.558 volts. The lead sulfate, if I turn that one around, is a negative 1.69 volts. And the SO2, if I turn that one around, is a negative 0.2 volts. None of those are positive values, but the one that is the most positive is the SO2. So SO2 becomes my best oxidizing agent, reducing agent because it gets oxidized the most easily. MnO2 is the second, and then the lead sulfate is the third in terms of reducing agents. So again, these are the oxidizing agents down here, and if I were to do reducing agents, I'm going to run out of space, but it was 1, then 2, and then 3. So SO2 was better than MnO2 was better than the lead sulfate. Okay, so that's how we got to take a look at these in terms of what's the best oxidizing agent and what's the best reducing agent. So my next question then is, can we do this for 3 other species? And so you may want to cut me off at, here shortly as soon as I ask the question, and that is, which of these 3 metals, mercury, iron, or tin, is the best reducing agent? Okay, I will stop here and let you take a look at that and then come back. Alright, so which one is the best reducing agent? A reducing agent again gets oxidized. And if it's getting oxidized, that means it has to be giving up electrons. So here's the iron giving up electrons if it goes in the reverse direction, mercury and tin, right? So of those, which one is the best, right? So we can take a look at this and say, okay, if we're looking at iron metal, mercury metal, and tin metal, we're going to have to turn the reactions around. That means we're going to have to take the negative of all of those E zeros, and then the question is which one is going to be the most positive. And so we find that iron is a better reducing agent than tin, which is a better reducing agent than mercury, right? So iron, then tin, then mercury. If I wanted to look at oxidizing agents, right, then I would have to have reactions where iron is going to gain some electrons and become an anion. And the thing is, we don't find any reactions where you end up getting iron becoming iron -2. I don't find any reactions where mercury becomes a negative mercury or tin becomes a negative tin. So these metals are not oxidizing agents at all. They are only reducing agents. Okay? Have a good day.